Today, let's talk about factors and multiples. Okay, so this is an important topic. So we're going to see what are factors and what are multiples and others that follow after them. Okay, so our learning objective here is to make sure that by the end of the lesson, you are going to be able to define and identify factors and multiples, odd and even number, and then the next thing is express numbers as a product of their prime factors. Okay, so we have to know what are prime factors first, what are prime numbers, then to see what are prime factors. Then the other thing is we are going to use prime factorization, this one, to find the highest common factor and the lowest common multiple of a number. Okay, that is going to be our objective. So next, let's go on to talk about key definitions of the numbers. Okay, the first definition is factors. Okay, let's know what are factors. Okay, so factors are whole numbers that divide exactly into another number. Okay, so this means that if you have a number, any whole number that divides exactly into that whole number is a factor. Let's say you have your number 4. You can see that 1, 2, and 4, they divide exactly into this number. Okay, so we can say that these 1, 2, 4 are factors of 4. Okay, so that's it. Okay, so let's say you have another number. Let's say you have 20. Okay, so you can see that 1, 2, 4, 5, 10, and 20. Okay, these numbers they divide exactly into 20. Okay, so you can say these are factors of 20. Okay, you include 1 because 1 can divide into any number. Then 20, we include that number because they divide into that number once. Okay, so these are factors. Let's go next and talk about multiples. Okay, multiples, they are numbers that found by multiplying a number by 2. Okay, so let's say we have 4. We want to find the multiples of 4. Okay, so are the numbers that are found by multiplying that 4 with 1, 2, 3. Okay, so if you multiply 4 by 1, you can say it's 4. If you multiply by 2, you can see it's 8. If you multiply by 3, you can see it's 12. Okay, and go and so on and so on. Okay, so these are what you call the multiples of 4. Okay, then let's go and talk about odd and even numbers. Okay, these are easy. Even numbers are every number which is divisible by 2. Okay, so we start from 0 is divisible by 2, 2, and so on, 2, 4, 6. These are even numbers. Okay, then we go on odd numbers, the numbers which are not divisible by 2. Okay, this means that when you divide it by 2, there is a remainder 1. Okay, so these numbers are 1, 3, 5, 7, 9, and go and so on and so on. Okay, so every number that divisible by 2, you can say it's even number. Every number that is not divisible by 2, you can say it's an odd number. Okay, now let's talk about prime and composite numbers. Okay, so the first one is prime number. Okay, a prime number is a number that has exactly 2 factors, 1 and itself. Okay, so when you talked about the factors in a number, we said that the number that divide into a number. Okay, so for example, 2 is a factor of 4 because 2 into 4 is 2. Okay, then so now we are talking about prime factors. Okay, it has exactly 2 factors. Let's take for example 2. Okay, let's list the factors of 2. We have the factors of 2. We have 1 and 2. Okay, and 3 we have 1 and 3. Then 4 we have 1, 2, and 4. Okay, so these ones they have only 2 factors. They are prime numbers. Okay, this one has 3 factors, so it's not a prime number. Okay, so a prime number is a number which has exactly 2 factors. Okay, so when you see a number asked if it's a prime or not, okay, you just have to check first, count the factors of that number. If there are 2, you can say it's prime. If there are more than 2, you can say it's not prime. Okay, so let's go on to the opposite of prime. Okay, it's a composite number. Okay, so this is a number that has more than 2 factors. Okay, so this means that 4 here is not a prime, it goes to a composite number. Okay, so this is the opposite of prime. It has more than 2 factors. Okay, so that's a composite number. For example, we have 4 and we have 6, 9, and so on. Okay, and 8. So these are our composite numbers. the numbers that is more than 2 factors. Okay. These are what we call composite numbers. Okay, so these are the opposite of prime numbers, composite numbers. Okay, so 0 is neither a prime or a compound, because if you multiply any number by 0, you get 0. Okay, so that one is not a composite number. Okay, next, let's talk about prime factorization. Okay, so its definition is writing a number as a product of prime numbers. Okay, so you are taking a number and writing it as a product of prime number. Okay, so let's see what does it mean. Okay, so let's say you are said to you have a question that say that express 36 as a product of its prime factors. Okay, so this is prime factorization. Okay, so you need to take 36. There are two methods. The first one is you use a prime factorization tree, and the second thing is you use prime factors from the smallest to the largest. Okay, so the first one is you are going to express 36 as a product of its prime factors. Okay, so the first one is the first thing you have to write 36 here, and so you'll be making like a tree. Okay, so here you have to find two factors of 36. Okay, so let's start with the 12 and 3. Okay, so you are going to put 3 here and 12 here. Okay, so now we have 3. 3 is a prime number. Okay, so this branch terminates here. Okay, so you have to branch again from 12, which is, let's say, 12 12 two factors of 12. How many, who are they? Let's say we have 4 and 3. Okay, so we have 3 and 4. Okay, so this means that we have a prime factor here, so we terminate this tree. Okay, so let's go and find two factors of 4, which are 2 and 2. Okay, so it becomes 2, and here it becomes 2. Okay, so now we can see that all the branches, they have prime factors. Okay, so we can now express 36 as the product of its prime factors, which are 2 times 2 times 3 times 3. Okay, that's how we do it using a prime factorization tree. Okay, so the next method is we just have to know prime factors from smallest to biggest, right? So the next thing is you write 36 like this, then you create a table like this. Okay, so you have to find the smallest prime number, which is a factor of 36. Okay, so here in this case we have 2. Okay, 36 is divisible by 2. Okay, so you're saying 2 into 36, you have 18. Okay, so you write 18 here. Then you find the smallest prime number, that is a factor of 18. Here we have 2 again. Okay, so 2 into 18 is 9. Okay, now again you find the smallest prime number, that is a factor of 9, which is in this case 3. Okay, so 3 into 9 is 3. Okay, nextly you have to find the smallest prime number, which is a factor of 3. Okay, here we have 3. Okay, so 3 into 3 becomes 1. Okay, so when you reach 1 here, you can simply say that you have found all the prime factors of 36. Okay, so now we can express prime 36 as a product of its prime factors. Okay, so now you have to say 36 is equals to 2 times 2 times 3 times 3. Okay, now you can see the answers are the same. Okay, so that's the only step here. Our next example, example 2. Okay, it states that express 360 as a product of its prime factors in index form. Okay, so our first step is to express 360 as a product of its prime factors. Then the next thing is to change it to index form. Okay, so I'm going to show you both. Okay, so let's say first express 360 as a product of its prime factors. The first thing you are going to be using a prime factorization tree. Okay, so in this case, we write 360 here. Then we find two factors in which if we multiply them, we get 360. In this case, let's say 10 and 36. Okay, so now let's go on. If this is not a prime number, we just have to find the factors again. Okay, so here we have 10. The other factors of 10, if we multiply, we get 10 are 2 and 5. Okay, then here we have our prime numbers. Okay, so now we can say we are done with this branch. Okay, then we go on to 36. This time let's try 9 and 4. Okay, these are not prime factors. Okay, so we have to branch again. Okay, so let's go on 9. The two factors, if we multiply, we get 9 are 3 and 3. Okay, here we can see that these are prime factors. Okay, so we conclude this branch. Then we go on 4. 4, the numbers, two numbers, if we multiply, we get 4 are 2 and 2. Okay, so it's 2 and 2. Okay, now you can see 2 and 2 are prime numbers. So now we conclude here. Okay, so after we conclude all the branches, we can now say that we have successfully changed 36 into product of its prime factors, which are, so you can now easily say 36 360 is equals to, okay, so you can say 2 times 2 is 2 times 2 times 2, okay, then times 3 times 3 times 3 times 3, then times 5. Okay, so now you can say you have successfully expressed 360 as a product of its prime factors. Okay, so now let's change them to index form. Okay, so changing these to index form, say that you just have to say 2, you have 2 here, so you say 2, then you count the number of 2s, so you have 1 2 3. Okay, so this means that it becomes 2 to the power 3, then you say times, now we have 3, how many 3's do we have? 1 2, so it becomes 3 to the power 2, then we have 5. Okay, 5 is, if it's only 1, you can just write 5. Okay, so now you can see that we have successfully changed these ones to index form. Okay, let's go to our next method, which is the prime factorization table. Okay, using this table, we have to find the smallest prime number, which is a factor of that number we have. Okay, so now we have 360. The smallest prime number here is 2. Okay, so we have to say 2 into 360, it's 180. Okay, and the smallest prime number here is still 2, so 2 into 180 is 90. Okay, the smallest prime number is still 2. Okay, so you have to say 2 into 90, we have a 45. Okay, so now the smallest prime number becomes 3. Okay, so we have 3 into 45, we have 15. Okay, so now the smallest prime number again is 3. Okay, so you can say 3 into 15 becomes 5. Okay, so now the smallest prime number becomes 5. 5 into 5 is 1. Okay, so when you reach 1 here, you can see easily say that I found prime numbers. Okay, so now you can see these numbers are the same as the numbers we found here. Okay, so you just have to write them 2 times 2 times 2 times 3 times 3 times 5. Okay, so you've expressed 360 as a product of its prime factor. Changing to index form is the same procedure. Just have to count number of numbers you have. Okay, let's go to our next concept, which is HCF and LCM using prime factorization. Okay, HCF is highest common factor, as LCM is lowest common multiple using prime factorization. Okay, so the first step is to express each number as a product of prime factors. Okay, so the first thing is to express each number as a product of prime factors. Then the step 2 is for HCF, take the common prime factors with smaller powers. For LCM is to take all prime factors with highest powers. Okay, so let's go and see how to do it. Okay, let's say, for example, you are given HCF and LCM of 9 and 12. Okay, find HCF and LCM of 9 and 12. Okay. So the first thing is to express 9 as a product of its prime factors. So we say 9, here we have is 3 times 3. Okay, so this means that 9 is equals to 3 times 3. Okay, these are the only prime factors. Then we have 12. Okay, so here 12, we have 4, we have 3 and 4, right? The next we have here is a prime factor. Then on this 4, we just have to say 2 and 2. Okay, so this means that our prime factors are 3, 2 and 2. Okay, so 12 is equals to 2 times 2 times 3. Okay, so now we have to find the lowest common multiple. Okay, so let's start with the HCF, highest common factor. Okay, so HCF is, we just have to find what is common here and here. Okay, so here we have 3 and 3. Okay, so we write here 3. Okay, so 3 becomes our HCF. Okay, the next LCM, we just have to multiply the remainings. Okay, so we just have to take this 3 times this 3 times this 2 times this 2. Okay, so this is the way. Okay, so we have multiplied 3 by 3, 2 times 2. Okay, so this becomes 9, this becomes 4. This means that this answer is plus 36. Okay, so this means that the highest common factor of 9 and 12 is 3, and the lowest common multiple of 9 and 12 is 36. Okay, so this is how do we do it. First, we have to express it as a product of its prime factor. Then we have to find what is common here and here. Then it's HCF. Then the remaining we just multiply it with HCF. Then we get our 36. Okay, let's see again next example. Our next example is find the HCF and lowest common multiple of 72, 90, and 120. Okay, so this is a long math. Okay, so I'm going to try to be fast. Okay, so the first thing is we are going to try to find, to express each number as a product of its prime factors. Okay, so let's start with 72. Okay, this is my easier way of doing it. 72. So we have 72 here. So let's find two numbers we can multiply to get 72. We have a 2 and 36. Okay, so if you are not sure, you just have to find any smaller number. You can start from there. It becomes easy as you go on. Okay, so now we have 2 is a prime factor, so we conclude here. Then we have 36. 36 we have here is 9 and 4. Okay, so here on 9 is 3 and 3. Then here on 4 is 2 and 2. Okay, so now we have our prime factors here. So okay, so this means that 72 uh, 72 can be expressed as a 2 times 2 times 2 times 3 times 3. Okay, so this is our expression for 72. Okay, so let's go on to the next, which is 90. Okay, so this one is easy. You just have to say 10 and 9. Okay, any factors you know, you just start with those, then it becomes easier. Okay, so the factors of 10 are 2 and 5. Okay, if you multiply this number, we should get this number. Make sure that if you multiply this number, we should get this number. Okay, here 9 we have 3 and 3. Okay, so this means that 90, if we express it, we have this 3, 3, 5, 2. Okay, so it equals to 2 times 3 times 3 times 5. Okay, let's go again. 120. Okay, so the first thing is, let's start with 10 and 12. Okay, if we multiply this, we get this one. Okay, so now 10 is 2 and 5. Okay, these are prime factors. Okay, here 12 is 3, this is a prime factor, and 4. Okay, 4 can be simplified to 2 and 2. Okay, so now this means that we have 2, 2, 2, 3, and 5. Okay, so this means that 120, okay, is equals to, let's say, 2 times 2 times 2 times 3 times 5. Okay, right. Now let's find the highest common factor. Okay, the highest common factor. It's easy. You just have to find the number which is common here, and multiply it with the next common number. Okay, so here we can see that 2 is there. Okay, so we can say that it's 2, 2, 2. Okay, so it becomes 2 here. We just have to find that. Then we multiply it by it. The other common number is 3. So we say 3, 3, 3. Okay, so this becomes 3. Okay, so this means that our highest common factor here, there is no other common number, right? 3, yeah, there's no other. Okay, so this means that our highest common factor is 6 here. Okay, so let's go to our lowest common multiple. Okay, our lowest common multiple, we have to take the HCF first, so it's 6 times. Okay, so now we have to take all the remaining numbers. Here we have to take, if this is common here and here, we just have to cancel it out again, right? So this means that is 2 and 2, then we write 2 here, and 2 and 2, then we write here 2. Okay, right? So now next we just have to multiply these numbers, these remaining ones. Okay, so this means that, oh, we have 3 again. 3 is common here and here, so it becomes 3 here. Okay, then we have 5 and 5 here, so it becomes 5 here. Okay, so now we have to multiply this 6 times 2 times 2 times 2 times 5. Okay, so this will require a calculator maybe. Okay, so the answer is 360. Okay, this will be our lowest common multiple. Okay, so the first thing is you're going to find everything which is common between the numbers, then you put it on HCF. Okay, so now we have to find the remaining. If it's common on two numbers, let's say this 3 was here and the other 3 was here, so we just have to cancel it out and put it here.